So an example from the homework says use the zero exponent rule to simplify the following expression. Okay, let me get an example over here. It's loading. Okay, so an example of using the zero exponent rule. If you're given negative 11 raised to the 0 power, we learned that with our zero rule, anything raised to the 0 power is 1. Okay. Evaluate the given exponential expression. So this one doesn't actually tell you in the homework to use a specific rule. It just tells you to evaluate. And what it gives us is a negative 4 raised to the 0 power. So this one can be tricky for some people. If you notice in this first example, the 11 was negative and it was inside of parentheses. So that 11 was with that negative. All of it was being raised to the 0 power, so all of it became 1. In this example, our 4 is being raised to the 0 power, and then on the outside, not included in parentheses, we have a negative sign. So we have our negative sign, and then we have our 4 being raised to the 0 power, which is always 1. That one actually ends up being negative 1. Okay, so let's do this example where it says use the quotient rule to simplify. So here it actually is giving you some hints and telling you what rule to apply. Just know that that won't always be the case. So use the quotient rule to simplify, and what we're given is x to the 4th, y to the 6th power divided by x squared, y to the 6th power. Okay, so using our exponent rules, if you remember, for our quotient rule, when you have the same power, I didn't just write a on the top and a on the bottom just to write a on the top and a on the bottom. I wrote it to actually express that these are the exact same thing, which is why we can apply this rule. So if you have the exact same variables raised to any power and they're dividing, you subtract the powers. So what I mean by that is I can only apply the rule here because I have the same variables, which are x's, and then I can apply the rule again here. Okay, you can't use an x up top and a y on the bottom. They have to be the same variables so that you can apply the rule. So if I apply the rule which says to keep your variable and subtract your exponents, keep your variable and subtract your exponents, right? So that's x to the 4 minus 2, and then y to the 6 minus 6. Well, x to the 4 minus 2 is just x squared, and then y 6 minus 6. So y 6 minus 6 is 0. Using that 0 rule, though, we know we have x squared because this goes to 1. So we actually have x squared times 1, which is just x squared. Okay. To the next example. Simplify the exponential expression. So it literally just tells you again just to simplify. In the numerator, we have a negative 20, x to the 10th power, y to the 6th power. And then in the denominator, we have 4, x to the 5th power, y cubed. Let's apply our rules. Well, if we look at our coefficients, 20 divided by 4, I can do that simply, and it would be in the numerator because it's not going to be a fraction. The largest number is on top. So if I look at it, I've got 20 divided by 4 is 5. Signs are different, so it's negative. And now let's apply our rules right here. X to the 10th divided by x to the 5th is keep and subtract. Y to the 6th divided by y cubed is keep, subtract. That's your final answer. Okay. So let me change papers. We are going to do, let me see if I want to do this one or the next one. I want to do a complicated one so that I know you'll know how to solve these problems. Okay, let's use this one. So this one just says simplify. Write each answer using positive exponents only. Remember, like I said, a